Okay, the next thing we're going to look at is this problem here. It has a -9 over there, so my first step, of course, is to get the -9 to the other side. So I'll need to add 9, adding 9 here, and then a -9 plus 9 will give me a 0. Now, remember, you could use quadratic formula with A is 4, B is -12, C is 9, but it's worth your while to look over here and just see what happens when you graph it. So if you do that, you have 4x squared minus 12x plus 9, I believe. Let me double check. Yes, that's correct. And I have an x-intercept that's relatively pretty. It's 1.5. Now, remember, if I want to see that in fractional form, because sometimes they'll have that as a fractional form, I can check and to see what fraction that is by looking at my factors of this 4. So factors of 4 include 1, 2, and 4. So I'm basically going to take my 1 and my 2 and my 4 and see which one of them gets rid of a 0.5. Well, multiplying by 1 never accomplishes anything as far as changing a number. So I could take my 1.5 and try multiplying it by 2. And that would mean one possible answer would be a 3/2, a 3/2. Another way is if this was multiple choice or something, I could have, of course, just typed in my 3/2 and saw that it was equal to 1.5. But if you have a 1.5, you can multiply it by 2, and that means the answer would be 3/2. And there's only one answer here because it only touches once. And the truth is, if you would have tried the quadratic formula on this one, the part inside the square root would have been 0. So that entire square root would have gone away, and you just would have had an answer that eventually reduces to 3/2 like this. Let's go ahead and look at one more. On the next one, I need to start by adding 1 to both sides. So that will give me a 10x squared minus 7x plus 1. This computer is going as fast as can be desired right now. So 10x squared minus 7x and a plus 1. And then I can go ahead and try that one by graphing 10x squared. Just change it up here, save myself a little bit of time maybe. Minus 7x plus 1. And this one looks kind of close there, but one thing I want you to notice is this is a good example that you better zoom in before you decide it only has one solution. Because when we zoom in on this, I actually find there's two different solutions. There is a 0.2 and there is a 0.5. So what I can do once again is I can remember I can take the numbers that multiply to 10. So in this case, the numbers that multiply to 10 are 1, 2, 5, and 10, and try to use those to convert those pretty decimals into a fractional form. So one of my decimals was a 0.5. You might be able to see, hey, 0.5 times 2 would give me a 1, so that means one of my answers is going to be 1/2. So one answer is 1/2 because that's the same thing as my 0.5. My other answer was 0.2, so I can go ahead and take my 0.2 and try multiplying it by 2. That doesn't get rid of the decimal. Multiplying by 1 never will. I can try multiplying by 5. So multiplying by 5 also gives me a 1, got rid of the decimal, so that's an answer of 1/5. So I have answers of 1/2 and 1/5. And the 1/5 was the same thing as the 0.2 right there, and the 1/2 was the same thing as the 0.5. Now, one thing that will work for some, but not all decimals with Desmos as well, is you could just try doing 0.2, and when it pops up this little fraction thing, click it, and it'll make it a fraction for you. The problem with that is sometimes if I have a repeating decimal like 0.3, it makes it a fraction, but I have to keep, since that's a repeating 3, I basically have to make it keep going until eventually it realizes that that should be a 1/3. And you notice the repeating 3, it doesn't convert. So that's the one reason I'm not a big fan. If you have a decimal that goes all 3 places, that could be a repeating decimal, it'll mess you up sometimes. So that's why I like multiplying by those numbers instead.